Over the years, there have been many requests for ITX to support variables inside of maps. And with version 10.002, that feature was added. So today we're going to look at just the basics of using the flow variables in mapping functions. They're composed of key value pairs. They can be either product defined, so there are some reserved variables. Today we're going to look at user-defined variables. You can set them and manipulate them through the web UI for the new Flow Designer, or as mapping functions in Design Server or Design Studio, and working with them in REST API. Today we're going to show a demo of some flow variables being manipulated in Design Studio and how they work. They're case sensitive. There's a specific syntax. In a mapping instance, the scope is the entire top level map run. So let's take a look at the functions that we have. The mapping functions are set variable, get variable, delete variable, inc variable, dec variable, and resolve variable. Here's a little description of each one, and they are in the documentation and they're on the on-screen help in the function pick section, and we'll take a look at that shortly. Here are some examples, and this is what your map rule will look like in your output. And today we're going to be doing an inc variable and a get variable in our map. The scope, if we're running under non-flow execution, so we're running in Design Studio, Command Server, or Launcher, it is the flow variables persist until the top level map completes execution. And they're active and accessible between the levels of maps the entire time of the execution. There is another type of variable called cache variables, and that will be a topic of a different video, but there are some similarities and some differences. And this chart, and in fact this whole deck, will be available in the ITX community. Thank you for watching, and check out the demo. So let's look at one quick example of using flow variables in Design Studio in mapping rules. So here I have a version of the example for states that comes with your IBM install. In this case, I'm using 10.1.1, and under Design Studio, we have examples, general, map, and states. And so it's a very, very simple example. So it's easy to show some concepts with. So here we have the maps. I have made some changes in order to add a variable, and so that you can see how they work. And in the case of the output card, where we have an array of states with some population information, at the end, I've added a total population bucket. So I've got a number that represents total population. What's happening here in this map? There's a file that has some information about the states. And let's actually quickly run this as it is and look at the input. So the input basically shows regions. Inside regions, each of the regions has states with some populations that we care about. And each state has the state code, a number for population, a number for income, a number for average temperature in summer, average temperature in winter, and average rainfall. And so we can see there's a whole bunch of states in 3 different regions in this input data, and not all of the states have a population number that is associated with the population that we care about in that state. So not all of these states in our case will be mapped across. And so if we look back at our map, we have our input that we just took a look at, and we have an output card, which is some statistics about the state. In this case, we have also the final total population. So we've got a variable that's keeping track of the final population, which is the total that we're going to be calculating from each of the calls of the functional map state. So if we look at map state, each of the state IDs that has a population, a non-zero population, will trigger the execution of the functional map. In the functional map, it's going to output the state ID. And here's the different thing. It's going to output the population and put that to the output, but it's also going to calculate a cumulative total of the population. So the population of the first state and the second state that had population and the third state. So it's a running total. And we're using a flow variable and setting it with an increment variable. So the first time we process it will come in as 0. It will take the population of the first state and then the second state and the third state and so on. So it's basically a tracking bucket for the population. If we look at our functions where in this case, we're using the increment variable. And so we have some basic information on how to use the increment variable. And that is what we were using to tally up that population. So back up in the master, how we are showing that is we're doing a get variable. So we're doing a get variable to output that population variable that we've been increasing each time in our functional map state. Because all of our variables are name value pairs and are completely text, I have to remember to do a to number so that I get something that is suitable for putting in my total population statistic. So once again, we look at the map we ran and the output, and you can see these are the states that had non-zero population, and we're showing the state and its population, state population, a very simple array. And then at the very end, I added the variable with a tag total pop, which has been adding up the populations that are on this report, and our total is 870. So very simple example, very useful. This can also be done in TX using extra scratch cards, but as you can see, no scratch cards necessary, and we have a pretty nice array of functions that let us manipulate these variables. Enjoy and good luck. Thank you.